Hello and hi everyone. So today, our group 3 will present the game theory, the analysis of the solution of ecological issue by using dynamic game approach. So here are the teams member. First we have Farhana, second we have Afika, and third one I'm Nadia, and the last one is
An article
Azima.
from Guardian states that more than 2/3 of the population of wildlife has been declined since 50 years ago. An International Fund or Animal Welfare (IFAO) states that there are top 10 ecological issues that affecting wildlife as stated in the slide. Some of it are natural phenomena that cannot controlled by human, but most of it are related with human activities, especially in the industry. The main reason of the ecological problems came from the human activity, especially from the industry. Thus, the government who have the power must play a crucial role before the extinction of wildlife population happens. But still, the environmental issues and economics needs to be balanced. The government can imply a policy, which they have two choices whether to be strict or lenient. The strict means the industry who exploit have to pay a fine and penalties if they are caught, while lenient, the industry would have tendencies to exploit the environment. While the industry also have two choices whether to comply with government's policies, which they are restricted to using natural resources, but the industry also can exploit where they can improve their profit as long as they not get caught. To solve this problem, we will use game theory approach, which is dynamic game with complete information. This is dynamic game since the player one, which is government, will play first and then followed by the player two, which is the industry. And it is complete information because both players know each other's payoff. Players, of course, the government and the industry. And the strategy, both players will have two strategy. The government, they have choose to strict or lenient with their policy, while the industry, they have choices which are to comply or to exploit the environment. And the payoff for the government and the industry is using the formula as stated in the slide.
Hi, I am Afika, and moving on to our case study. On the left side of the slide, you see the extensive form of this game. The game starts with the government as the first move. They can either implement strict enforcement or lenient enforcement. Once the government makes its decision, it is the industry's turn to move. The industry observes the government's policy and then decide whether to comply with the regulation or exploit the environment for economic gain. This sequence leads to four possible terminal outcomes with the associated payoff listed. The first number represents the government's utility and the second number represents the industry's payoff. As detailed in our report, this payoff will calculate using specific utility function incorporating variables. To identify the stable outcomes of this interaction, we convert extensive form into the normal form as you can see on the right. Here the row represents the government strategies and the column represents the industry's complete sets of conditional strategies. For example, comply if strict but exploit if lenient. We have used yellow highlight to indicate the best response for each player. Where the best response for both players intersect, we find a Nash equilibrium. On the right, the number shows which outcomes are the most stable. So we found two main scenarios, the best and the worst. The best case is strict and comply. If the government sets strict rules, the industry is forced to comply. The worst case is lenient and exploit. If the government is lenient, the industry will likely to choose to exploit. This result said that the industry makes the highest possible profit because penalties are low but the environment suffers significantly. To verify our result, we use the game bit to model the interaction. We start by rename player 1 to government and player 2 to industry. Next, we construct the game tree. We insert a move for the government at the root node, giving them two possible branches. After that, we insert move for the industry on both subsequent nodes. Then we input the specific terminal payoff and calculate earlier. Then we continue this for all four terminal nodes respectively. For each branch, we label the government branch as strict and lenient, and the industry as comply and exploit. We first select compute one Nash equilibrium, so this shows the SPNE. Then we select compute all Nash equilibria, then it shows mixed and pure strategy. To verify our result, we use the game bit to model the interaction. We start by
Okay,
rename.
I'm Nadia, so I will continue slide from Africa. So I will present the result of the Cambit output. For the first figure, it shows that the output of all Nash equilibrium that we got from our extensive form. So the figure 2 show that the output that we have, it have 3 pure strategy and 1 mixed strategy. So here are the output from the result of Cambit. Okay, I will continue to next slide. The figure 3, it shows the SPNE result. The SPNE result is shown as in the slide. So from the output, it shows that player will make their move by according to the listed probabilities of 1 and 0, that indicating a pure strategy profile. The following discussion path highlight in the red and blue where probabilities are 1 and the government choose strict and the industry subsequently choose comply. The SPNE sub-game perfect Nash equilibrium is 60-42, which correspond to the strict and comply, the strategy set by the players and by the players. This result is consistent with the manual backward induction calculation performed earlier. That's all. I give to the next
My name
presenter.
is Nura Azlifa binti Azni, and I will continue with discussion. So, this game involves 2 players, which are the government and the industry. And it is a dynamic game with complete information since both players know each other's strategies and payoff. The government moves first by choosing either a strict or lenient environmental policy, and then the industry responds after observing this decision. Using backward induction, the government can predict the industry's direction. When a strict policy is enforced, the industry prefers to comply because exploiting the environment will result in penalties and lower payoff. On the other hand, under a lenient policy, exploitation becomes more attractive due to weak enforcement. Based on the results obtained from Gambit, the unique sub-game perfect Nash equilibrium is strict and comply, with a payoff of 60 for the government and 42 for the industry. This outcome shows that strict environmental enforcement encourages industry compliance and leads to better outcomes for conclusion. This study applies game theory to analyze environmental issues that affect wildlife by examining the strategic decisions of the government and the industry. The problem is modeled as 2 players dynamic game with complete information, and the equilibria are identified using Gambit software. Although the game has multiple Nash equilibria, sub-game perfect Nash equilibrium provides the most suitable solution for this dynamic setting. The outcome is strict and comply, where the government enforces strict regulations and the industry chooses to comply. This outcome benefits both players as it helps protect the environment while still allowing the industry to earn reasonable profits. For future works, the model can be improved by including more realistic factors such as uncertainty in enforcement, repeated interactions over time, and the use of real-world data to estimate payoff more accurately. These extensions would allow the model to better represent real environmental and economic situations to support better policy decision-making. These are the references we use for our study. So, that's all from us. Thank you.